Today, we're going to pull back the curtain on the invisible architecture that quite literally holds our world together. We're talking about the unseen blueprint that shapes everything around us from the ground up. Have you ever done that? You're driving over some massive bridge, or you're standing at the bottom of a skyscraper just looking straight up, and you get that little thought in your head, how in the world is this thing not falling down? It almost feels like it's defying physics, but it's not magic. It's engineering. And that's exactly what we're getting into. See, there's this hidden framework, this invisible blueprint that's all built on physics, math, and just some incredibly careful planning. It's what makes our entire modern world possible. And it all starts way before a single piece of steel ever gets hoisted into the air. Okay, so to really understand this blueprint, we first have to talk about the two main players behind it, civil and structural engineering. Now, they sound pretty similar, right? And yeah, they work hand in hand. But they actually have very different jobs when it comes to designing the world we live in. Here's probably the best way to think about it. Imagine a project is like a human body. Civil engineering is, well, it's the entire system. The roads are the circulatory system. The drainage is like the lymphatic system. It's the big picture stuff that makes everything work together as a whole. But structural engineering, that's the skeleton. It's the core frame, the bones, that gives the body its strength and lets it stand up tall. So yeah, civil engineering is all about that macro level. It's the art and science of making a place functional. Civil engineers figure out the site, they design the roads to get you there, they create the systems that keep it from flooding every time it rains, and they make sure the whole project actually works with the environment around it. They're asking, where does this go and how does it connect to everything else? And then you have structural engineering, which zooms way in on the building or the bridge itself. Its job is all about strength and stability, period. They're asking the really critical questions, like, is this beam strong enough to hold the weight? Is the foundation solid? Will this thing be able to withstand a hurricane or an earthquake? It's really the science of making sure things don't fall down. And when you bring these two together, that's where the magic happens. The civil engineer creates this perfectly functional site, and the structural engineer makes sure the buildings on it are rock solid and safe. It's that seamless partnership that creates projects built not just for us today, but for generations to come. All right, so we get the what, but how do engineers actually go from a vision, an idea on a piece of paper to, a real thing? Let's take a look at the actual toolkit they use to build our world. Everything, and I mean everything, starts with laying the groundwork. You've got the planning phase, which means really deep site analysis and making sure you're following all the local zoning laws. Then you've got these incredible surveys that create super precise 3D maps of the land. This step is absolutely crucial for avoiding expensive surprises later. And finally, all that data feeds into the design drawings, the ultimate master plan for construction. And once that groundwork is laid, that's when engineers can start building all the connections we rely on every single day. They design road networks for smooth, safe traffic. They create these complex stormwater systems so our towns don't flood. And they design strong, durable bridges that connect our communities. These aren't just bonus features. They are the absolute essentials that make our neighborhoods work. Okay, now here is a massive challenge on any big project. Think about it. You have the structure, right? But then you also have plumbing, electrical wiring, HVAC systems. How do you make sure all of that fits together without literally running into each other? You can't just run a giant pipe through a main support beam. This is one of the trickiest puzzles for engineers to solve. And the solution really comes down to two key things. First, technology. They use amazing digital tools like 3D modeling, specifically something called Building Information Modeling, or BIM, to basically build the entire project in a computer first. You can spot all the conflicts before a single shovel ever hits the dirt. And second, it's just pure teamwork. You have civil, mechanical, and electrical engineers all talking to each other constantly, making sure every single system is perfectly integrated from day one. That saves a ton of time and money. So we've covered the what and the how. Now let's get to the most important part, the why. What's the real payoff for all this incredibly detailed planning and design? Why does this foundation matter so much? Let's just ask it directly. For the people funding the project, for the cities, and for all of us who use these spaces, what is the actual real-world impact of getting this engineering right from the very beginning? It really breaks down into 4 huge benefits, 4 pillars of a strong foundation. First, you've got regulatory compliance. That just means everything is up to code and you won't get shut down. Second, cost efficiency.
Good planning up front means you avoid those super expensive on-site fixes. Third, and maybe most important, longevity and safety. The thing is built to last and, of course, keep people safe. And finally, future-proofing, designing it in a way that it's ready for tomorrow's technology and needs. That's the true payoff. And this idea of future-proofing brings us to our final section. Because really, great engineering isn't just about what we can build right now. It's about laying the foundation for a better, more resilient, and more sustainable future.
You know, the best engineering happening today is always looking ahead. It's about weaving sustainable and eco-friendly ideas into every single design. Things like smarter water management or using greener building materials. And it's also about creating infrastructure that can adapt, adapt to new tech and the changing needs of our communities, making sure our world is ready for whatever comes next.
This quote just nails it, doesn't it? The work of these engineers is about so much more than just concrete and steel. It's really about this profound responsibility they have to design a world that's not only safe and functional for us today, but one that's sustainable for all the generations that will come after us. So I'll leave you with this final thought. The world we live in today was built from the blueprints of the past. The big question for all of us now is, what's the next great challenge? What is the next innovative blueprint that we need to start designing right now? Thanks for tuning in.